Question 3. 3 points A, B, C lie on plane π1. Find the vector AB and the vector AC. Vector AB use easy, ending minus starting point. 0, -2, 0. Minus 3, 0, 0. Equals -3, -2, 0. AC equals 1, 1, -7 minus 3, 0, 0 equals -2, 1, -7. B. Hence, find the equation of π1, expressing your answer in form ax plus by plus cz equals d. A, B, C, D are integers. We do know in this form, normal vector equals A, B, C. And also this normal vector equals vector AB cross vector AC. So normal vector equals vector AB cross vector AC equals -3, -2, 0 cross -2, 1, -7 equals, cross out the first row, then determinant of this remaining matrices. -2 times -7 is 14 minus 0 times 1 is 0. Then cross out the second row. Since we got separated matrix, remember we need to put a negative sign. -3 times -7, 21 minus 0 times -2 is 0. Then we cross out the third row. -3 times 1 is -3 minus -2 times -2 is +4. Work this out. 14, -21, -7. We will take out a common factor, which is 7. Normally, we always take out the positive common factor. So we get 2, -3, -1. We want to make a normal vector 2, -3, -1. So let's label vector n1 equals vector AB cross vector AC. This D equals position vector times this normal vector. We will use position vector OA, which is 3, 0, 0, dot normal vector 2, -3, -1 equals 6. So the equation of the plane π1 is x, y, z dot normal vector 2, -3, -1 equals 6, which is 2x minus 3y minus z equals 6. This is the equation for π1. Say, plane π2 has equation 3x minus y plus 2z equals 2. The line L is the intersection of π1 and π2. Verify that the vector equation of L can be written as R equals this. We will change this into parametric form. X equals lambda, y equals -2 plus lambda, z equals negative lambda. Then we do the substitution to pi 1 and pi 2. For the pi 1, 2 times x, which is lambda, minus 3 times -2 plus lambda, minus negative lambda. Work this out. 2 lambda plus 6 minus 3 lambda plus lambda equals 6. So this line is on pi 1. For pi 2, 3 times lambda minus -2 plus lambda plus 2 times negative lambda equals 3 lambda plus 2 minus lambda minus 2 lambda equals 2, which means this line is on pi 2. So R equals 0, -2, 0 plus lambda 1, 1, -1 is the equation of L. Let's go to D. The plane pi 3 is given by 2x minus 2z equals 3. The line L and the plane pi 3 intersects at point P. Show that at point P, lambda equals 3/4. Suppose this is the plane pi 3. This is the line L. We need to figure out this intersection. This is the intersection P. Since P is on line L, we can write down the coordinates using this parametric form. Lambda, -2 plus lambda, negative lambda. Then we do the substitution. We know pi 3, 2x minus 2z equals 3. Now do the substitution. 2 times lambda minus 2 times negative lambda equals 3. 4 lambda equals 3. So lambda equals 3/4. For E, hence find the coordinates of P. Do the substitution. Lambda equals 3/4. 3/4. -2 plus 3/4. -3/4. Work this out. Coordinates of P, 3/4. -5/4. -3/4. Let's go to F. The points B, 0, -2, 0 lies on L. Find the shortest distance from B to the plane pi 3. Let's draw this diagram. This is the plane pi 3. This is the line L. Point B is on the line L. We draw this perpendicular line to the plane pi 3. Intersection is B prime. We do know this direction vector for the line B prime is normal vector of the plane pi 3. The equation of pi 3 2x minus 2z equals 3. Normal vector equals 2, 0, negative 2. So we can write down the vector equation of the line B prime. R equals position vector 0, negative 2, 0 plus. Since we already used the lambda in previous question, we will use mu this time. Direction vector 2, 0, negative 2. We will change this into parametric form. X equals 2 mu. Y equals negative 2. Z equals negative 2 mu. So the coordinates of B prime is 2 mu, negative 2, negative 2 mu. B prime is on the plane pi 3. So we do the substitution. 2 times 2 mu minus 2 times negative 2 mu equals 3. Simplify. 8 mu equals 3. So mu equals 3 over 8. Then the coordinates of B prime will be 2 times 3 over 8 is 3 over 4. Negative 2. Negative 3 over 4. So the shortest distance from B to the plane pi 3 equals square root. Coordinates of B 0, negative 2, 0. Coordinates of B prime 3 over 4, negative 2, negative 3 over 4. 0 minus 3 over 4 squared plus negative 2 minus negative 2 is 0 squared plus 0 plus 3 over 4 squared equals square root 2 times 9 over 16. Take out 9 over 16, 3 over 4 square root of 2. B. Find the reflection of the point B in the plane pi 3. This is the answer for B. G. Hence, find the vector equation of the line formed when L is reflected in the plane pi 3. We know the point P 3 over 4, negative 5 over 4, negative 3 over 4, and B prime 3 over 4, negative 2, negative 3 over 4. We are looking for vector equation. So we need to figure out the vector PB prime equals ending minus starting 3 over 4, negative 2, negative 3 over 4, minus 3 over 4, negative 5 over 4, negative 3 over 4. Change the sign, then adding equals 0, negative 3 over 4, 0, We can take this 3/4 out because this is a direction vector. 0, -1, 0. So the vector equation equals 3/4, -2, -3/4, plus t, 0, -1, 0. Let's go to H. Hence, find the angle formed between L and the plane pi3. Let's draw this diagram. The direction vector for this L is 1, 1, -1. The normal vector of the plane pi3 is 2, 0, -2. Let's label. This is alpha, this is theta. So cosine theta equals 1, 1, -1 dot 2, 0, -2 over square root 1 square plus 1 square plus -1 square times square root 2 square plus 0 square plus -2 square. Work this out. 1 times 2 is 2. 1 times 0 is 0 plus -1 times -2 is 2 all over square root of 3 times square root of 8 equals 4 over 2 square root of 6. We don't need to simplify. Let's go to calculator. Make sure this is a degree. Then trig, go to inverse cosine of control divide 4 over 2 square root of 6. Enter. Then use 90 minus this. We got the angle between the line and the plane pi3. So we got theta equals 35.2644. And the angle between the line L and pi3, alpha equals 90 degree minus theta, which is 54.7 degree.